maybe I'll try to give a little bit of an overview. Like people sort of, I think, recognize if we're talking about a superintelligent system and full interpretability, like that's not tractable. Like it's just clear that you cannot like feasibly do this. And so there's a bit of a question, like where do you check out? You can have interpretability in terms of, okay, you have a simple system, like a reasonably simple system where you can study important principles, and that can be fully interpretable maybe. And you can have some theories about why that interpretability should scale. Hopefully you can, by studying the simpler system, detect some like qualities or markers, like some more abstract variables that you can check that will serve as an indication for what's going on under the hood, as a sort of abstraction in a way, like you're hoping to extract some useful information from this sort of lower circuit. This is an abstraction, but like if you study the underlying thing, then there's some hope, or like there's some theories according to which you can sort of scale in that way. And then, so you're looking at a more abstract version of the system and can interpret the abstract version, but it's just a sort of placeholder for the actual more complex version, and you have some theory that tells you why that should work. And obviously you're also going to do some experiments, but like in practice, there's going to be, like, it's probably only going to be probabilistic, because, like, to the extent to which the more detailed system is doing more.
But the abstraction is the central problem that we are trying to deal with, right? Because at this moment, the models works in a very abstract and encapsulated way. We don't know what they're doing. So we need to get like a clear understanding, a detailed understanding of the model. That is interpretability. That is what we want. But making it more abstract, that is already abstract, will be like way too vague for one to abstract. What do you exactly mean by abstract, I guess? First, let me know that.
So with abstract, I always mean lower resolution, like just lower than full resolution. Usually, we're talking about useful abstractions, so there's some sensible way of zooming out from a lot of information to sort of extract just relevant information. Maybe the information that is still going to be reasonably predictive of the more complicated system, and that's a useful abstraction, for example.
Okay, so by abstraction you basically means some filtration process of important aspects.
That is one, like, the important aspects is going to be like a useful abstraction. Abstraction is more generally for me this process, like a filtration process, if you want to put it that way, yeah.
Okay.
Like there can be different categories of abstraction. It's not always going to be about pure usefulness.
Okay. And your take is that instead of doing it rigorously to like to the extreme form, we must do it to a certain limit till which it becomes useful enough, right?
Like one thing that I'm sort of more curious about is like having interpretability at multiple levels of resolution sort of simultaneously. So you have some interpretability on the super detailed level, but you cannot track all of the detailed level, so you're just sort of checking at certain points in your network, whatever, and see whether you can predict things there. Then you have a more abstract level where you can sort of track a larger portion of the overall system, but at lower resolution. And you have multiple such levels. Like this is one interpretability approach that I would find like more compelling, for example. And the way that I usually think of this is, okay, there's obviously some things with interpretability that we cannot do. Like ultimately we want to predict the behavior of these systems. But the sort of next best thing is to at least like predict boundary conditions. Like if I'm interacting with humans, the interaction, like the behavior of the individual human is pretty complicated. I cannot predict it in detail, but I know that they will obey certain social norms most of the time. So I can like make a little frame, like a little boundary around their behavior, and I can say, okay, they will jump around in this frame and they will do all sorts of unpredictable stuff, but they will sort of stay within this boundary pretty much all of the time. And this is the only thing that I need in order to have them like be reasonably predictive for the things that I care about. I don't need the full resolution thing. And like this is something that I think is at least a sensible approach. Like, can we do something similar with AI systems?
So
sort of
basically like having some specific critical points or milestone points for interpretability, like at this point we want it to be interpretable and explainable, and also having the boundary conditions more clear, right?
Yeah.
Okay, but okay, in this is what I was getting. The problem is, again, how do we know what are the actually milestone points and how do we define those boundaries? Because even if we are able to do that, then we are limiting the model. We are not supposed to do that.
Yeah, I'd be curious. I agree with that, but I'd be curious why you think it's not good to model the AI, to sort of limit the model.
Because limiting model, we might not be able to get some new level of insights that the model might produce, that are outside those boundary conditions, that actually not be that harmful. Like outside boundaries, it is not necessary that the things are bad only. There are good things also and bad things also. Basically we will not reach the epitome of like best possible conditions if we are bounding the model in a system where it is also being saved from a worst possible condition. Like best and worst both lies in the extremes only. And we are designing this whole thing, we are doing the whole of science technology to get to better state, and the better state is at extreme at some level.
I do. Okay, yeah, I think I have a bit of a different opinion on this, in the sense that I think you probably want to have an iterative process, and avoiding extreme bad outcomes is more important than like correctly aiming at extreme good outcomes, because you get to sort of re-aim unless you hit a bad outcome, and so you can sort of iteratively like increase the boundaries as you go forward. I don't think that the first AIs that we design don't need to have any boundaries, because that will restrict them in that way.
Okay, so
I
avoiding
think there's some theory according to which you still wouldn't want to restrict them. For instance, if you really want them to become autonomous, if you think that's like the best way, then certain kinds of, like most kinds of restrictions are not going to be very good. But just in principle, from what you're saying, I think an iterative process of like getting to re-aim towards a good thing again and again seems more compelling to me.
okay, so changing boundaries after reaching the boundary, but initially setting a lower boundary.
Yeah.
Okay, and same goes for the critical point and the milestone thing as well. Like setting milestones after each point and each level.
You could do it that way, yeah.
Okay.
But I'm not really advocating for this. I think just
but in
it's
both of
useful
the
to notice that this is sensible.
But in both of the conditions, it is limited by human mind and human capabilities to be able to put the milestones and to be able to put the boundaries. And how we are designing things that are supposed to surpass humans' intelligence.
Yeah, I mean, look, the thing is going to surpass humanity just by virtue of speed alone, right? Like if it has similar cognitive capabilities than a human in terms of like the kinds of models that it can figure out from how much data, still going to be much faster, and it can like probably interface with like data a lot better. So you already have something that's superhumanly capable, and the question is, can you make this thing safe before you go outside of human boundaries in terms of how well we can model the world and sort of what we can understand that well.
Okay, so basically it's like your assumption is we have to make it safe till the human boundaries, and then when it goes beyond human boundaries, it will be safe because it is safe till before the limit, right?
Yeah, I think there's a sort of transition point. Like if you can make a human level system safe, then you can sort of use that system for safety work, like at a probably slightly superhuman scale. And at that point, you sort of hand the alignment problem over almost. Like it's okay at that point.
And on what are you like basing this on? Like based on what you can say that like why it is supposed to be like this? Why it will be safe beyond human limits? Like is there any rule, or it will be emergent property, or why it will be safe beyond human boundaries?
Slightly complicated explanation, but like it will probably be safe beyond human boundaries because the process by which you expand boundaries is going to be sort of corrective. So
Okay.
the idea is like for instance, you could have the AI run with a sort of non-interference policy that is coupled with whatever else it is doing. So unless it is very certain, like it doesn't want to alter the causal trajectory of the universe, like let's say the local universe, too much, unless it is sort of very certain that it's doing the right thing. So while it's still figuring things out, it doesn't want to sort of do cost too much. Like whenever it's unlocking new, like going past previous boundaries, this sort of principle would be pretty strong, and so it would sort of experiment in a cautious way with the sort of newly accessible horizon, like within the newly accessible conceptual territory, basically, and like try to aim for instance, reversible states or experiments and so on. Like you can probably, I think you can sort of formalize this. Like I'm pretty confident that you can do it that way, because the way in which you expand the boundary is going to be a computational thing. Like the way that you expand the horizon. Like, and if that is a computational thing that then you can sort of predict ahead of time what kind of patterns you are sort of unlocking within the new territory, basically, and whether you will be able to, like, deal with them by virtue of having sort of figured other things out. Like, there's some, I think you can, like, the system is always going to be able to evaluate another system that's slightly more capable than itself, just by taking more time to sort of do this evaluation. So you can, for instance, run a careful evaluation of how you would behave if you upgraded yourself before the upgrade. And then if you sort of run this test, then you can sort of do the upgrade. This is the more empirical way. I think there are also more principled ways that can guide you along that path.
Okay, yeah. Okay, now let us just like come to the points that we were discussing in the chat, or the thing that I got. So yeah, actually point of interpretations and recursive problem, like what about that thing? Like I have heard this in some video, or like some call of some people were doing, like interpretability seems like a we are making mathematical models to explain mathematical models. What about this assessment? Like how is this wrong and where does it fall out?
Whenever I give an explanation for a phenomenon, the level of resolution of that explanation is going to be, like, what a good explanation is going to be context dependent. And I think this is also sort of true for modeling things. Like, having different salient resolutions to something is relevant. And depending on how deeply you need to interact with the system, you want to have these available to sort of to choose from and to sort of do, like, also inference between, like, if you can have like different systems at different levels of resolution, you can sort of reason about them in a much more complete fashion compared to if you just had, for instance, if you didn't know at what level of resolution you're at with your current perception of a system. And I think, like, a certain principle, that doesn't need to be a bad idea of sort of making multiple mathematical models sort of stacked on top of each other. There's just a sort of principle, like, how do you construct this in a way that you expect to be useful? Like, for what context this is going to be useful?
And not making it recursively, but making it only till a point till it becomes efficient enough, and only using this like specific instances of the model, right?
Yeah.
Okay. So again, the scalable problem that I mentioned in the mail, like how are we supposed to deal with that? When the model will scale, the amount of snapshots or the instances will also scale, and it will cause problem again. Then we will have to do something for that thing as well.
There's a sort of just a scale problem,
like
overall, when these systems get too large and the thing, like the data that they're manipulating and so on, is too complicated. Like, you cannot have a human judge that looks into this and can tell whether the model's decision was correct and so on. It's just too big.
So how we'll do on larger scale?
Ideally, at that point, we don't need human oversight anymore. Like, you just make systems at sort of human scale of reasoning safe and have a robust way of them scaling themselves. So I call this a self-alignment agenda. This is a thing that I'm pursuing. Like, I'm really interested in, for instance, thinking about the minimal environment within which an AI can be, like, really aligned with a human or whatever, like a more simple environment than our environment. Like, what would it mean for the AI to be aligned within that sort of environment? And then think about how can you make this environment slightly more complicated. Like, there's, like, for instance, I think currently like 4 categorical ways in which you can make an environment more complicated. And along each of these ways, how would the current alignment of the AI have to get updated in order to sort of adjust to the new layer or level of complexity? And if you could solve that, it's still sort of working on this, for instance, but if you could solve that, you can sort of do this even beyond the scale at which we humans, like right now, we perceive our environment in a certain way, we understand it in a certain way, but understanding it more deeply, like unlocking more layers of, like, looking into the elementary particles and so on. This is sort of almost similar to if we found out that our environment is getting upgraded with additional complexity that we didn't sort of know what was there before. And I think there's some equivalency between these two processes of you, like, figuring out a deeper layer of your environment versus your environment just actually getting upgraded, although it's not quite the same thing. And like, for instance, for a solution like that, it would be really nice to have an AI that you can sort of scale from a simpler environment in sort of alignment to eventually, in a very controlled fashion, to, okay, it's aligned with humans in our kind of environment, while it's still at human capability. And the same principle that guided this path will also sort of let it go further. And the responsibility at this point is on the AI. Like, we don't pretend that we can control or understand what's going to happen past this point. We just trust that this process will continue because we've identified the right principles, and the AI was also sort of trying to do the right thing, and more capable than us, increasingly so.
And this also
And sort of
follows
carrying the alignment along.
this also follows the earlier logic of that it will be like self-correcting in a way after, like, when it becomes scalable at last level, right?
Yeah, I think like this is my main hope for how things would actually work. I don't think you can use a superintelligence as a tool without something like this.
Okay. And like, I know it's like ridiculous, but why are we only choosing human as the benchmark thing? Like, we earlier we chose human for defining the boundary for the AI. Now we are using human for making it more interpretable. Why are we only choosing the human level as the level for machines? Because that's what we can understand. Is it the reason? Like, why?
Yeah, sort of. Like, the thing is, I personally believe, okay, humans are, like, we're sort of Turing complete in our ability to sort of think about the world. Like, we can make computational models about our environment. And we have certain talents in this, like some kinds of heuristics we're really good at generating, others not so much. And I don't know, like, certainly humans have, in this context, what I would call a sort of limited general intelligence. And like, that is a good benchmark that we don't really see anywhere else to sort of study. So we can sort of think about AI, if we want to, relative to that, and okay, it's also a limited general intelligence, but it just has sort of different talents initially, just by how the hardware works and so on. And we can think about how to sort of even these things out or how to compare them. But I'm, like, in my own work, I'm often trying to not restrict myself to thinking about human minds when doing these things. I would like to have a more principled solution than that. Like, I don't want to have to rely on this.
Because
although I do think in practice it's going to be, like, I can't predict what all of the difficulties will be, so I want to have a training set up in which I can have the expectation that human researchers participating in the training will be able to sort of come up with interesting insights during the process. So that means it shouldn't be beyond the scope of human understanding what's happening in there. So it sort of needs to be roughly leveled towards that. There's also, like, our ability to come up with a theory of optimal, or like, of good improvement, right? So if you train a system in general, there's always going to be an appropriate level of challenge for the sort of learning that you want. Like, it sort of like, if it tries to understand an environment, and you're sort of saying, okay, once it has figured out how to navigate this environment reasonably well, I'm going to make the environment more complicated, like I'm introducing new features or something like this. And there's a theory about, okay, what is the optimal level of pressure for the learning? What is the optimal level of challenge as to facilitate the sort of growth that you're interested in? And I think we're pretty early in, like, having good theories about that, and a lot of it is really oriented in sort of human learning, like how children unlock different layers of sort of understanding the world and, like, making models of it and so on. I think that's pretty restrictive, but like, it's the best thing to go from now if you want to have, like, any empirical grounding in this.
Okay, because what I was thinking, if we do something, we obviously cannot go above human intelligence to set the boundary, because it will be testing in a chaotic area. But we can do this training testing thing by making the boundaries that are below human intelligence. Like, we can make the boundaries below human intelligence and let it grow and see if it is self-correcting till human level, like second boundary. The primary boundary should be, like, below human level, and then if it is working good enough till there, then we can, like, let it go beyond human level, or we can just stop it. The corrigibility problem.
Exactly. Like, you should have a good theory for why you expect it to still go correctly after human level as well.
So that's
but the empirical test of going from below human level to a human level in the way that you predicted, where it correctly self-aligned, from the simpler environment to our level, that would be really good evidence
to say that
to
it will
have
also
if you
work
want to launch a
properly.
superintelligence.
Yeah. But I've been thinking about this, but again, the problem in this thought is the levels at which humans are a very critical level. And if we define, like, there is a huge jump kind of thing, it's not very gradual that we can work out.
Yeah,
And
yeah, I'm also sort of worrying about that.
yeah, and after
I think,
human also, it will be a jump, not a gradual growth, as it happens with humans.
so one thing is, if your model, like if your agent is doing something like Bayesian learning, Bayesian sort of updating about the world, you can raise this agent in a sort of toy environment that is sort of much simpler than the real world. And in that context, you still have a lot of control over the information that the agent gets access to, and therefore also about what the most likely theories are that this agent would form about its surroundings, like even the meta theories and so on. Like if it sort of discovers Occam's razor, you have a lot of control over what to show it. It cannot know out of all the possible ways in which it's being tricked or trained, like which world it would be. And so, like, you can have like pretty strong information theoretical guarantees for, like, I actually have the sort of sovereignty about like this basically human level intelligent agent because I sort of really control the data that this agent is learning from, and therefore what kind of theories it can form. Like, this is sort of one assurance that you have for restricting its ability to reason about the world, because it sort of, even if it gets more competent, it cannot get fundamentally more informed about some of the things that would be relevant for planning dangerous things. And you can also, one thing I was really thinking about recently is sort of proto-language. Like, I think as soon as a system learns to really use abstractions in a sort of versatile way, you almost automatically unlock, or it's a biological concept, I don't know if you're familiar with it. It's called exaptation. And it's sort of how one feature is expressed more and more strongly, often by evolutionary selection. And at some point, the feature is so strongly expressed that you unlock a new ability. So one easy to imagine example is sort of gliding, and how that can eventually turn into flying ability. The more basic example that I like is if you have a cell that can detect light, like it's just a simple light sensor, and it's sort of just the intensity of light, and can sort of use that to swim towards the light, because there's going to be plankton and it can eat that or something like this nearer to the light. And if you have more light sensors, that is going to help you with like better detecting where the light is and being sort of slightly more efficient and sort of finding this in more like slightly more chaotic environments, like going to the light source better. But if you have a sufficient number of light sensors next to each other, you have a small screen, and that screen allows you to detect shapes of like what kind of shadow you are seeing, and maybe you should react differently to different shadows. And just by wanting to localize light better, you sort of unlock this ability to see shadows and then respond to that, which is sort of the precursor to more sophisticated vision and response to things that are still away from you because you can already see them. And like these are sort of two examples for exaptation. And I think it's similar here, where you already have the cognitive machinery to deal with abstractions. And now, like, this sort of proto-language is like, you can think about certain things in the environment symbolize other things. Like maybe there's a red flag over there, and that tells me, oh, in this region they're going to be, like, I know this signifies something. This gives me the information about some more precise state over there in the environment. Like maybe there are pine trees in that environment, or there are apples to be found there, or something else. Maybe it's colder there. There could be, like, it could be a symbol for different things. And that is in principle the same thing as when like a human NPC in the environment utters like a series of noises, and you also interpret this as a signal that also has a meaning for some other place in the environment, for instance. Okay. And that thing, like figuring out there can be abstract meanings, like symbols that signal, that tell you something about a different thing in the environment, not just in your own cognition as sort of simplifications of like this is an abstraction away from the thing, like this symbolizes another thing. I think, yeah, like I think even in relatively simple environments, an agent can, if you sort of, as it gets slightly more sophisticated, discover sort of proto-language. Still trying to figure out how far that we'll be able to develop that. But Yeah, like as soon as you have a system in your training environment that actually figures out how a good language sort of works, like because it's very useful to put things into language, sort of because it's cognitive outsourcing of stuff. Like it's much more efficient to write something down, for instance, compared to the equivalent operation if you didn't have language.
And the
yeah, so sort of thinking about how capability levels just get automatically unlocked by stuff like this.
Language abstraction, yeah. So the abstraction thing that you're all talking about, basically, it is like a power up to the intelligence thing. And what I've been saying it from a different reference of ethics thing. It's like the intermediate tool that we need to jump from intelligence to something above intelligence. The power up that is needed for that jump from intelligence to superintelligence. Superintelligence also with ethics that are representing. But so yeah, abstraction is again like a plug-in thing to intelligence that gives more power, right? This is the basic thing.
Yeah, I think this is pretty much correct, yeah. Like, I think animals can also form abstractions, but they're sort of
Not
often
that
pretty
strong.
limited in that.
Yeah.
And just having a free ability to form abstractions is going to, like, supercharge what you can do with a given level of intelligence and, like, have, like, unlock some meta layers and, like, just making better models about how you should look at the situation and so on. Like, what to pay attention to, for instance. Like, an animal cannot calibrate this as well without some level of abstraction. That humans can sort of learn to pay attention to completely different nuances of the same scene.
So what I'm doing right now, or what I'm working through this AI thing, is with safety. And recently I got to know that my work is not with safety, it is AI safety with ethics, it is by ethics. So all of these concepts are coming into my workaround as well, abstraction and all, but I'm trying to build them for realizations and making machines have wisdom enough that they don't need to be aligned. Again, this is also my point that machines should be self-aligning, like they should know what is wrong and right by themselves, because humans cannot guide forever and beyond human boundaries we do not know. But for doing that, my approach is all from ethics and philosophical point of view. And when I'm going through that, and I'm like current project that I'm working on, CQA, in that I have reached a point where I'm trying to define, like till now humans machines have knowledge because they can simulate intelligence of humans, but similar to that, humans have other aspect of wisdom that they also have, based on which they work with the knowledge properly in a sane manner. So my goal at this moment is to use ethical and philosophical manners to make machines also have wisdom along with intelligence, like different aspect building a different concept from all together from starting, and then use wisdom and intelligence both together to make the machines align and make it them more sensible. So for making this wisdom thing, the integral thing that humans have at this moment is realization. Until we have the pure and good enough amount of abstraction of the concept, we don't have realization of the knowledge that we have, the machines have. This is the fundamental problem. They just know, it's like the Chinese room. They're taking input, they're giving output, there's no realization of the concept. So what I'm trying to do through the ethics thing is build realization. And while building realization, the next thing I was doing was making new equations and new perceptron, new backpropagation, new reinforcement learning. While making them, like I read this for algorithm of Jeffrey Hinton. If you have read it, it is so properly written and made that if we derive some things from it, if we take something from it and modify it bit, it can properly simulate and all the functionalities of backpropagation, but for realization. We can do the same thing that we do for backpropagation in intelligence. We can do the same things using forward for realization, but we need something for reinforcement.
I want to check that out, but I haven't read it yet.
There is no paper or there is nothing like that that talks about reinforcement learning in similar manner, like long-term learning, the other features that reinforcement learning offers, because the forward algorithm offers tweak up to the backpropagation, not to the reinforcement learning. So it is like taking both and combining. So for designing the reinforcement learning of realization sector, of wisdom sector, I was following a different route. And while following that different route, I came across that FFAEE, that is fundamental fluid abstract exploration, endless exploration, as we have. The name is all chaotic at this manner. I'm still working on these things. And when I saw your videos and how you were talking about abstraction, like agent foundation view, and like any sufficiently sophisticated embedded cognition probably converges towards natural abstraction, all that thing, it all clicked and it all seemed like fitting properly into my topics, into my things that I'm also working on. Yeah, no, I'm not trying to upgrade AI with wisdom. That's the fundamental thing that I've been trying to tell a lot of people who talk. It's a new paradigm itself. Like, it's not like upgrading AI to also have wisdom. It's like making artificial wisdom itself and then combining it with AI. It's not upgrading AI. That's different, because again, if you go towards philosophical grounds, then no amount of intelligence can lead to wisdom. It's a philosophical thing. A lot of philosophers talk about it, and no amount of logic can lead to virtue and ethics. So it's not like I want to build ethics and wisdom onto intelligence. It's a different thing that I have to build, and then we can combine it or make it entangle with intelligence and work as proper as humans doing themselves. Humans also have these two different aspects.
Yeah, let me just flag that I'm not convinced of this yet.
Okay, of what? Like, exactly what?
That there's a strong divide between intelligence and wisdom, that you can never get to wisdom through just intelligence and so on. I'm like thinking maybe this requires a definition of the terms that either I don't agree with, or that might be a little bit unclear, or that might be too human-centric. I'm not really sure. I just think that right now I'm not convinced that this divide exists.
By wisdom, there are a lot of definitions and unclear ways to define wisdom. I define wisdom is something for now that helps machine to get aligned with us. That is wisdom in normal sense. Having more power than something else, but still not dominating that thing. That is wisdom. Is what I am taking right now. And talking about why we need a whole different paradigm. So it has a lot of big roots in the ethics, philosophy of ethics. In that also it is mentioned in a lot of different ways, using different statements by a lot of philosophers. But it's like a common ground there only itself, that no amount of intelligence can lead to wisdom. Intelligence is a different aspect. I guess recently I saw a post of Ilya Sutskever on Twitter that also said the same thing. If only you are using intelligence, you can only go so far. Even if we assume this thing at the base, that we need a different paradigm. So this is what I was doing, and I'm going through a different way. And in that, after encountering forward algorithm working proper with backpropagation, I was trying to make this new thing. Okay, but before talking more about it, can you like explain your terms and your things a bit more? What you meant by this convergence toward constructive simulation and natural abstraction, all these concepts, and also what I mentioned in the mail earlier, because I did not understand that term properly when I saw your recording.
So I started thinking about AI risk, and I really wanted to make up my own mind about things. Like, I think often if there's a lot of disagreement between the experts and so on, or like people are really confused about the problem, then maybe it's more fundamental. Like, if I follow the same education path as all the people who are confused, maybe I'll also be confused in a way that I don't even like realize when it happens, because I just sort of take along some assumptions that I'm not in a position to check or whatever. Like, I just wanted to sort of do it on my own. And so I have many concepts that are sort of my concepts, and I sort of need to translate them a little bit for people. And I think you're sort of familiar with that process. So I was thinking a lot about. So one thing I was thinking about is, okay, what is intelligence really? And I was like making headway on this, and I was saying, oh yeah, it relates a lot to prediction ability, and sort of this gives you power because you can sort of steer by predicting the consequences of your own actions. You can sort of choose from multiple options if you want to, and you can sort of improve that power by like building better and better models. And for an embedded agent, that is like the environment is more complicated than the agent. Building good models, like what does this really mean to have a better and better ability to build good models that predict the things that you want to manipulate in the world? And sort of from that whole like category of thinking, I sort of came to certain views on abstraction and like how an agent would probably efficiently develop if it was sort of free to develop in sort of any way, and if it was just trying to get better at this sort of modeling thing, if it could improve in arbitrary ways, but also always just gradually, like what would this improvement probably look like in like different environments? I was sort of doing many thought experiments about this, and like the short version of this is sort of, okay, I think an embedded agent that is sort of trying to achieve goals within an environment that is more complicated than the agent itself. What the agent sort of learns is to run internally in its cognition a sort of simulation of the environment or of the like local environment surrounding it. So it's a sort of constructive simulation because there may be multiple places in the larger environment and you cannot simulate the whole larger environment at once. So you need to be able to sort of build, like construct as a simulation, the current scene that you want to manipulate. So that's sort of what I basically mean with constructive simulation. The simulation is basically you have some version of the environment, some representation of the environment that sort of flows forward in time. You can sort of compute that, and you can sort of basically you predict your own action given the fact that you want to achieve certain outcomes or want to get closer to certain states. Make certain states more likely, perhaps, the different vocabulary for this. But like that's sort of the simulation aspect. And there are many reasons, like in other literature and other sort of fields, why this sort of simulation thing makes a lot of sense. So, for instance, for compression, a lot of people were thinking, like historically in intelligence research also, that like intelligence is fundamentally about how well you can compress information. And I don't think that's sort of quite on the mark, but it's related. And here simulation is, we can also see, simulation is a really good way of compressing a lot of complex information. If I give you a video of an apple falling down, then if you have a simulator, you maybe only need the very first image because the simulator knows the gravity constant, and so you can recover all the other images from just the first image. And more than that, you probably don't even need to encode the full first image. You probably, in your simulator, you know what an apple is. And the apple in the picture, in the frame that you have left, it has some deviation from the default apple that you understand. So you only need to encode this deviation rather than the full picture of the apple with all of the complexity, and so on and so forth. So if you want to recover some complex data, what you basically do, you just reduce the original data to some small, almost like a key, that you then can later put into the simulator to uncover the full data, because the simulator knows the same rules that were true in the environment in which the data occurred, so it can sort of regenerate the process according to which the data or like the observations or whatever formed. So this is a very strong principle of compression. Doesn't mean that an agent always needs to do this. It makes sense that humans had to do this because we are very restricted by skull size. Like evolution really tried to push that far. Our storage capacity is not so great relative to like the
machines
processing that we can do. Like we can sort of think pretty, like we can think many thoughts in like a relatively short span of time, but our skulls are only so big. So it makes more sense to have a stronger simulation capacity and not store that much away. For an AI, it's a little bit more arbitrary. Like some things, you don't want to have the extra effort of like simulating everything again when you could also just store it away. You just have much more storage capacity. So the trade-offs are going to be different. But it's still a fundamental thing about compression. Like simulation is just really useful for that. If you are very limited and your environment is really complicated, this is the way to go about it. I became pretty certain of that on sort of computational grounds, and I checked it out from multiple perspectives, and that sort of made a lot of sense. And related to that is a sort of second principle that is context refinement. I was also talking about this in the presentation. Context refinement is like, you can see it with large language models to some degree, you can sort of see it generally. Like there's only so much that you can pay attention to at once, even though you maybe know a lot of stuff. Like you cannot incorporate all of the things that you know into your current thinking about the situation. You sort of need to be clever about which pieces of the picture you include in your current view on it. And like one way of improving this ability is to sort of have a very good abstraction ability, because that means that you can really adjust well, like what you're paying attention to and what not. You don't need to have the whole package. You can reduce the package to only the relevant bits and sort of include that. But it's basically a big question of what exactly to pay attention to, what to have at high levels of resolution versus what to have at lower levels of resolution, that sort of thing. And like concepts like these, I just sort of derived more or less from first principles, and sort of just try to check them with all of the literature and different fields that I sort of found that sort of connected to this stuff. And like that's how I got to some of these. I think these are just principles that I would expect. Like if an agent is free to develop in some environment, like a cognitive agent, if it doesn't have that many constraints on its development, it would probably follow these principles. Like this is sort of a theory or like a hypothesis. And an implication of this hypothesis is we probably want to design our training trajectories, like our training methods and our architectures even, sort of to incorporate these principles so that they will sort of naturally flow into the way that we've already designed, rather than sort of working against our design. Like maybe there's a like very natural way for cognition to have like 3 layers. And if you are hell-bent on implementing a 2-layer architecture, it's going to find some weird convoluted way of putting 3 layers into your 2-layer architecture, and it's going to be much less interpretable.
Mm-hmm.
And like this is one goal of this. Like you want to make it more interpretable. You don't want it to find any weird solutions for things that you were constraining. Like that's sort of part of the reasoning there, and part of like why figuring this out sort of is supposed to make the thing overall more explainable. Even though it's also like dual-edged. Right, it's like also trying to find insights into how agents optimally develop, right, and like that can be misused. So I don't usually share all of the details of like what I would predict. I'm just sort of trying to like show people why certain principles make sense and why we should sort of pay attention to that.
Okay, so okay, what I can understand is like the squeeze theorem. You're trying to do something like that. Basically, this attention simulation thing that you're doing, it is similar to the transformer thing that we do, like self-attention thing, or using attention as a major thing, like what actually to focus on. So it's not about making simulation, but making simulation for specific things, for a specified thing to focus on in that simulation. And also goes for abstraction. So it's like way of increasing attention in the abstraction. The other way is like you are also defining the context from like environment. You're also defining the environment, and that is like the upper bound to lower bound. This is what I can see this thing as. So so if there is this one specific threshold amount at which it's like proper amount of attention also, and the environment is also like good enough complex, or right amount of complex. So by context refinement, we need to bring the environment to the correct amount of complexity, and by attention simulation we need to bring the agent to correct amount of abstraction. And when they both fit, there's this proper interpretability thing. So it's like finding
this sort of core mathematical principle in this that I call referential containment. So the idea with referential containment is, let's say you have a chaotic system, like there's just points that behave in some way, let's say, and like they're just sort of floating around or whatever, and it's like it's a big box with like 1 trillion points that are sort of floating around in there, and I'm trying to sort of find ways of sensibly zooming out of this. Like maybe I want to have a representation of these trillion points in like, maybe between 1 and 10 million objects that I want to sort of allow. Like what is a good way of reducing these points to like larger objects? And I can always see like maybe there, like if I just look at it visually, like maybe I see some structure there, like maybe there's like one cloud, like point cloud floating over there, and I can see, that's one object. And this really depends on the level of resolution, like how many salient levels of resolution are there that you can sort of do there. And this is sort of more general way of thinking about like, well, this is just a sort of illustration of how can you sensibly like simplify sort of complex structure into like a simpler structure. Like there's a correct operation there. Like you could reduce things by sort of 1 layer of resolution again and again and again until you hit a point where, this is like a very salient way. Like it's much more sensible to represent this as, let's say, 10 objects rather than 15 objects. Like 10 much better captures what's sort of going on than 15. And this is going to be true multiple times, like for 1 trillion things. It's going to be, you will have sort of salient levels of like, this is an appropriate level of resolution. You're going to have this multiple times throughout this whole thing. Like maybe, there are human bodies out there, and like one good layer of resolution is like taking account of the cells. And this is like a layer of resolution that sort of sees the cells and sort of like distinguishes them. Other layer might be the organs, I don't know. And like then you have the individuals, and then you have the whole tribe thing and so on. Like they're going to be salient levels of resolution. And why are they salient? So sort of for multiple reasons. Like one reason is subjective. which kinds of predictions are you interested in making? Which kinds of problems are you interested in solving? Like, that thing is subjective, but there's also an objective component to this, which is just computational reducibility. How many predictions about the overall system can you still make based on the simplification that you made? This is, I think, sort of largely objective. Like, there's some complex systems that you can sort of reduce to an abstraction of the system, and you can still predict most of the behavior of the complex system. And the other complex system for this is just simply not true. They're very difficult to sort of computationally reduce without losing a lot of prediction accuracy about what will happen. And like, often sort of it's sort of balancing out how you want to sort of correctly zoom in and out of concept space for like interpreting something. That is going to be like guided by these two principles. Like the more objective one, like how good are you at figuring out the computational reducibility of the system in front of you, and how good are you sort of at zeroing in on, okay, what is the correct level of representation and resolution for the problems that I'm actually trying to solve, and the sort of cognitive equipment that I have for that. Like, this is sort of a deeper principle from which you can sort of emerge more of the sort of context refinement and sort of abstraction formation stuff.
Narrowing it from both sides, not just approaching the problem from one side. Okay, good. But yeah, one thing I still don't understand, why you have like used the word natural multiple times in the presentation and in the point also. What is natural about this thing? Why you're always talking about natural convergence or natural abstract? What is natural in this thing, and what would be artificial abstraction?
So one thing I'm referencing is a popular theory in alignment, like in the alignment field. There's this guy, John Wentworth, and he has this natural abstractions hypothesis.
Okay.
And what he's basically saying with this hypothesis, and you know, a lot of people are fans of this, is to say, hey, probably AI systems will form similar abstractions about the world as we do. Like, they will summarize content in similar ways. There's going to be like convergence in how different cognitive systems with different goals and different sensors, even for the same environment, will learn to think about abstractly about that environment. And that's an hypothesis. Like, you don't really know whether that's true or not, and you can sort of investigate what are the reasons as to why these would be similar. And if this is similar across many agents, then you call it natural. Like, then this is just it's not really agent dependent. You could say it's convergent to some degree. But this is sort of what natural means in this context. So similarly, when I'm sort of calling something else natural, then I'm sort of saying, I'm expecting that most agents under these circumstances, like, you can have a lot of variety in design, and this thing should still be true. Like, I'm trying to make a pretty general statement about this. That's often what I sort of mean by natural. Natural as opposed to contrived or only under specific circumstances.
And applicable on most and in general on agents, right?
Yeah.
What I'm working through and the way I'm going through that way, it does not seem that it is natural, or it is an emergent quality that comes automatically. The ability to get to be able to do abstraction at that level, and in that amount and in that quality as humans are doing based on their amount of knowledge. Abstraction is it's a plugin, and I like completely agree with all of those things that you're talking about. It's a good important plugin and all, but what I'm thinking and what the way that I've been working on this, it does not seem to be just emergent. Similar to other things, we also need to make it happen. It will not just emerge from the underlying concepts that is already going on.
Yeah.
And like similar to your quotation, that abstraction is a good plugin to intelligence for greater power. What I'm seeing abstraction as is as an intermediate state for machines to also have wisdom along with this power. So for me, abstraction is the intermediate state for wisdom. Knowledge is said to be understood when we are able to make it abstract or make abstractions of that concept. From scientists and all, like all the scientific inquiries are being able to make this much advancement because of the ability of humans to make abstractions of the things first in their mind or first in some like non-physical way and then make it real. So abstraction is a really great power. That whole thing is completely true, and I agree. The before point of fluid and fundamental is the thing that you're talking about, that the attentive thing, that we need to make the abstraction of the very fundamental things, not of anything, but fundamental things, the most important and integral thing for any further concept. So if we have concept of gravity, we need to make abstraction of the very fundamental thing of gravity, of attraction, or whatever it is. We just don't need to make any all the thing that gravity can do. like all possible think of solar system and all, the most fundamental thing and concept of gravity, the most important first principle concept. And by fluid I mean being able to transfer or being able to transit from the fundamental to the most extreme concept, or to most extreme implementation of that concept, all in the abstraction form only, without getting to the implementation form. And this is all been done in abstraction. And by endless exploration I mean doing this in iteratively till like no end. This is what I was basically trying to do. But again, since we are coming from a different route, you are coming it from an interpretability route, so what does all that have to do with in like abstraction? Like what is the use of proper application of abstraction in interpretability?
If we think about an agent pursuing an objective, the objective actually usually ends up being an abstract thing, because like even if you have an agent that's just interested in eating fruit or whatever, in the concrete environment you don't have the goal of like eating fruit. Like sometimes you have, but if there's not if there's a fruit over there, then your goal is to sort of go over there, like navigate your environment around obstacles or whatever to sort of go to that visible piece of fruit. If you don't see a fruit, then like consult your heuristic, your map, your environmental clues, your memory, whatever, to sort of figure out like where should I maybe move so that there's a good chance that I will encounter fruit or something like this. And so objectives are more abstract, and they get sort of concretized into a sort of very concrete objective that is very like scene dependent. It's always in the context of the current scene that the agent is in. It's constructing an objective that is appropriate for the current context and is sort of connected to the sort of larger objective that it has. And that operation is just really important for being able to sort of figure out the boundaries of the agent's behavior, basically, because you will understand how will it sort of go downwards the abstraction, like how will it concretize the abstraction of its goal to like different behavior in different scenarios. Because if it now encounters a new scenario that it never was in before, we want to be able to predict how it might behave in that scenario. And this is largely dependent on how it concretizes its sort of more abstract objective into something sort of tangible in the context of the current environment. So understanding this relationship of zooming in and out, like building an abstraction out of like multiple pieces of behavior or observations, or like applying an abstraction to a current context and thereby sort of concretizing it down to a particular behavior, particular focus, attention, whatever. These two operations, this is just really important to have like good theory on if you want to draw predictive boundaries around your agent's behavior and therefore like have good interpretability of that aspect.
Okay. Of the thing that you're talking, it's basically the fundamental fluid thing. But so you're doing all of this basically to be able to draw the boundary and to set the milestones. For you,
not just that, but like the interpretability benefit is drawing the boundary.
Okay, so
like I'm interested in this for more reasons than just interpretability. On that level, like I'm also just thinking what is fundamentally good agent design, and like what kind of agent would I expect to carry like good alignment concepts. Like for instance, at some point I want the agent to be able to sort of reward itself partially for like having the right behavior. Like I would like to sort of gradually hand the reins over to the agent, and like as long as the humans are still like rewarding half, let's say, if the agent just always gives itself a high score even though it does the wrong thing, then our evaluation will really drop, and it can at some point only get 50% score maximum because our evaluation is down in the cellar. So it will have to learn to give itself the appropriate level of reward so that it's still going to predict and give itself the kind of reward that we would give it. And like this is one sort of project that I'm interested in. This is not as much about interpretability. This is just about like guiding and growing an agent, like with different features. And like the abstraction stuff is useful for that as well.
Proper and sensible rewarding. It is for that also.
Yeah, like and sort of how can self-reward work in principle? Like as a bit of a like I don't know, like a related concept to sort of self-alignment, I guess.
Okay, so like self-rewarding so that it can lead to self-alignment in a way.
Yeah.
Okay.
Yeah. You don't want the agent to sort of become super pleasure-seeking as soon as it's only self-dependent.
And self-rewarding method. Okay.
Yeah.
Okay. So
Like sensible self-rewarding is, I think, going into the direction of what you're talking about with wisdom. But your thing is probably going to be more like complex than what I've sort of currently figured out with the sort of self-rewarding thing. It hasn't been a strong focus so far, like because I've just been figuring out other stuff. But it's like I think it's important. I want to get to that.
Okay, so like any other purpose for this? You said you have multiple. So like boundary, milestone, self-rewarding. What other purpose?
Yeah.
Natural abstraction.
So I have like a list. I haven't slept this night, so I'm not as fit as I sometimes am, but I'm still keeping up pretty well, so I'm happy with that.
We can read some later if you like. I'm free most.
I have listed with like 60 like relevant ideas, 61 at this point.
Okay.
Like many of them are somewhat related. Not all of them, but it's like a big network for me, and like I can sort of go like a couple of edges further to sort of connect more things to it. It's not there's not just this very limited list that I could easily like give you of what it's relevant for. Like it's just an integral part of how I'm sort of modeling all of this so far.
I understand. I don't have like list of ideas. I have chunks of ideas. Like there's whole chunk of concept of all this realization and this other concept and chunks of quantum computation working of human mind. So I have these chunks, like I guess 7 and 8 I have not quantized, and like I'm trying to stitch all these quantized all these chunks together to form a theory or next project of mine, complete quantum existence, and also some concepts of philosophy as well of what is human existence and how does human use their existence to sense of consciousness, artificial consciousness, all this stuff, majorly from philosophy background and all. So I understand this point. You are more, but you're more precise than me. You have points, and I'm in general format of having chunks of concepts. So
I think I could also imagine myself using chunks. Like I'm just sort of really trying to like get the individual nodes and then sort of see the connections. Because like really understanding something well often for me means sort of turning it into the smallest, most universal building block that I can then sort of use for other stuff.
The recursive programming method. Okay, good. So I understood your point, and I guess this is what I had to add. Okay, so if you make some more progress in this abstraction thing, then just let me know. I guess it will be helpful to me as well to know more things about abstraction, because there are some other concepts close by to these concepts. I saw these concepts were concerning to you also, so I thought it would be good to talk to you.